In mathematics, when we're talking about functions, functions have actually two basic, or three, but really two basic operations. One is multiplication, or excuse me, addition, and the second one is what's called composition. And composition is, from a theoretical standpoint, can be kind of difficult for students to understand. I know you've seen it. You've seen it a lot inside of algebra, and I know you've seen it inside of calculus. But what we're going to do is we're going to start to understand it from the set theoretic standpoint. All right, so we're going to add another layer to it, and then I'm going to briefly review how we do things algebraically. Okay, but what we want to do is we first want to see, okay, we've got a notation for composition. So we'll have, suppose, right, we have F going from A into B, and we have G going from B into C. Okay, all right. We'll say, okay, so G of F, and we have this little thing, G of F of, call it X, right, is going to be equal to G of F of X, right? And this whole function, which you can call it H, you can call it whatever it wants, but what it's going to be defined from is it's going to go from A into C, okay? So it's going to go from A into C. Its codomain is going to be what happens when you finish with C, okay? And you're going to start out over here in A, right? Couple things that we want to get is that when we do composition, okay, we start on the inside, what we call on the inside position. So we're starting on the inside. So we'll start with F. That's the first function that we're going to use to operate on the members of our domain. And that's why we're going to start in A. We start in A because we're starting with F, and F starts in A. Then F is going to go into B, okay? And then we're going to operate using G, and G is going to take the elements that it got from F, and it's going to go into C, okay? So what we're going to look at here, okay, and then this comes second. Mapping picture in order to kind of like imagine what this looks like. So I start over here, I'm going to start in A, all right? And I'm going to operate using F, and that's going to go to into B. And then I'm going to operate again using G, and that's going to go into C, okay? So I'm going to say, all right, well, I'm going to take an element from A. It's going to take me to somewhere in B, okay? I'm going to have, basically a range, right? Here's my range of F, okay? Range of F. And then I'm going to take elements from that range of F, and they're going to go into C, and this is basically going to be the range of G, and it's going to be the range of G restricted to the range of F, right? So like the idea here is that I can't pull anything out of B unless it's in the range of F, because I started over here in A, right? I took all the elements of A and I used F, and they only went into the range of F. Then I'm going to operate on them again, like I'm going to lily pad jump over using G into C. But that's going to be restricted. It's going to be double restricted, okay? The first restriction is going to be the restriction to the only domain that we have for G here is all the range of F, and then the other restriction is whatever G does, okay? So let's take a look at this, and let's use some functions that actually have some of those restrictions to kind of understand what this looks like. So let's take F, and we're going to go from R to R, all right? And that's going to be, we're going to use F of X equals X squared, which we already know has some restrictions on its codomain, right? There's some things that it can't get to. Its range is limited. Then we're going to have G, and G is going to go from R to R again, okay? But G of X, we'll let that equal 3x plus 1, right? There it is. And what we're going to do is we're going to draw a picture of G of F. So we're going to operate on G of F, and so G of F is going to just go from R, because that's the domain of F, onto the codomain of G. Okay. All right, cool. So, all right, we'll start over here in R, and then we're going to operate using f of x equals x squared, and we're going to end up again in R again, right? except for the fact that we're not really going to end up in R, we're going to end up in R plus 0. Okay, so we're going to end up in R plus 0, right? So we won't be able to get -1 won't be allowed to be gotten. -2, can't do it. -5, can't do it, okay? Because once we take x squared, we're only going to get 0 and above, all the non-negative values. Then, okay, next up, I'm going to pull from all the positive values, and I'm going to use g, okay? And that's going to then also restrict r, okay? So I'm going to pull here, I'm going to use g, it's going to restrict r. And let's kind of look at what that looks like, okay? So like, say for example, well, one is that we know, okay, like 3x plus 1, yes, okay, is going to multiply x, right? Multiplies x by 1. And then adds 1. Okay? And the smallest value, because what we've done, right, we've picked out values from the real numbers, we've gone into, right, into the only the non-negative values, the smallest value that I can get for x is going to be 0. So f, or actually in this case, a g of x, right, okay, equal to 3x plus 1, we have our x's have to be greater than or equal to 0, so g of 0, right, is going to equal 3 times 0 plus 1, right? And so, which equals 1, so g, this domain over here, or actually this value, this set over here, has to be the real numbers, okay, the set of all x belonging to the reals, such that x is greater than or equal to 1. There's no way for me to actually get a smaller number, right? I'm going to start out here with all the numbers that are bigger than 0, and then I'm going to pop over into here using 3x plus 1. Well, that means that I'm not going to get any value that actually is going to be less than 1, all right? So now my codomain, pretty restricted, okay? So f of g, okay, or g of f, excuse me, g of f, right, okay, has a range of x greater than or equal to 1. Excuse me, g of f of x greater than or equal to 1. Okay. So since what we have is we have the values in that range have to be greater than or equal to 1, g of f of x has a range of g of f having to be greater than or equal to 1. Okay? And so you can see, like, just thinking about it from a composition standpoint can be quite a bit more difficult, right? We have to think about it in terms of its progression. We're going to do f first and then g second. Okay? So you really, like, logically speaking, you want to think about it in terms of the movement from like one of our lily pads to the next lily pad. Okay? All right. There it is. Now, we have seen this before then, okay? So g of f of x, right, is going to equal g defined at x squared, right? And if you remember from your algebra, that's then going to be 3x squared plus 1, right? That's our new function. So what we're going to do instead of composition is we're going to plug in the value for x squared into every value for, the value of f in for every value of x and g, and then that then becomes our new value, okay? And you can kind of see here, you could actually do this since, right, x squared must be greater than that 3x squared plus 1 has to be greater than or equal to 1, right? And there's just a little bit of algebra that goes into that, okay? And that's kind of like how we think about composition. Now, we can actually go the other way around too. We can go f of g of x. So what about f of g of x? Okay? Well, remember that G will go first. G goes from R to R. All right? And that's G of X equals 3x plus 1. And if you remember, 3x plus 1 was in fact a bijection, so it's going to give us everything in R, right? It's on 2, and so consequently it's going to give us everything in R. Now, next, we're going to take f. We're going to f of x equal to x squared. Well, f of x equals x squared is only going to take us onto a subset, right? It's going to take us onto r plus 0, right? So that's the non-negative values of x. The non-negative values of x. And so consequently, what we get is we get that our codomain for the entire function, right, is r, but our range for the entire function is now just r plus 0. Okay? So the range for f of g of x is r plus 0, right? Or f of g of x greater than or equal to 0. Those are the only values that we could possibly have. Okay? And then if we're going to calculate that, we have f of g of x is going to equal f of, in this case, 3x plus 1, right, which equals 3x plus 1 squared, which equals 9x squared plus 6x plus 1. Okay. So that's the composition of functions. Basically what we're trying to get at here is we're trying to understand the idea that when we compose two functions, right, we are actually moving from one domain into the range of the first function, and then using that range of the first function as the domain of the second function, right? And what it does is it ends up restricting the kinds of outputs that we might possibly get, okay? And so this is kind of the idea of composition of functions from a mathematical perspective.